Hello everyone, Anthony here with episode 6 of creating a modular production-ready blockchain from scratch in Golang. And today we're gonna continue the blockchain data structure because it's not complete. Let me quickly check what we did. Initial layout of the blockchain data structure, yeah. First of all, I'm gonna open up blockchain and our validator. Alright, and let me bump the font size because I was watching my own videos and I think it's okay, but still it could be better if it's a little bit higher. So let's do it like this. Okay, let me quickly inspect what we need to do because I think so basically, let's open the validator on this screen actually, like this, and blockchain test on the other side. Yeah. So we have our blockchain, which is responsible for adding blocks and basically retrieving blocks and maintaining a list of headers and all that Gucci stuff. And we have a validator, which basically validates the block, and this needs to be a little bit expanded. Because right now we say if we have the block, then it's not valid. But what happens if we do this? Let me create a new test. So test adds block to high. Testing.t. Yeah. Like this. And we're gonna say assert not null t bcp and adds block random block with signature t, and we're going to say 3 height 3. What's going on? T 1 2 3, yeah, okay, cool. So if we're adding a block that's too high, we should fail. And I don't think that's the case. Oh, make run, that's not what we want to do. Make test rather. Yeah, so our test is failing. To fix this, we're gonna say if the height of the block is not equal to v and bc and height plus 1. So basically this means that if the block is not coming exactly after the current height, it's too high, because we already checked if it's too low, so it's too high. Yeah, so we're gonna return error f block too high. Let's say some debug stuff. Block too high. Deep and hash. Default. No, what is it? Block hash it. Block hash it. Okay. So right now this should pass. Make test. Yeah, we fixed this. All right. The next thing, what we're gonna do is we're gonna check, because if we open up our block, we have a pref block hash. So we're gonna check if this block comes in, for example with height 5, we're gonna get block 4, we're gonna hash that block header, and we're gonna compare. And if those two are the same, we are all set, it's all fine. If not, we gonna return. So we're gonna do, so the pref header is gonna be v.bc.headers, or we could do ref headers hash is v.bc.get header. Do we have get headers? We don't have it. Okay. We don't have get header, so let's quickly fix this. Blockchain get header, and we're gonna say height UN32, which will return a header or an error, and we're gonna say, first of all, we're gonna check if the height should be smaller or equal than the bc.height. If it's not, if it's bigger actually, then we're gonna return nil. Height too high. And maybe we should do something like this. Explicit given height too high. And otherwise we're gonna return bc.headers height. It's basically an issue because that's an int. That's actually wrong. We're gonna say it's height plus 1, I guess. Or am I stupid? So let's say we want header 1, which basically means that we have 2 in the array. So it's 1 plus 2, yeah. We should make a test for this, to be honest. But first, let's do bc.get headers. We want b.height minus 1. If there's an error, we're gonna say return an error. And we gonna wait, let's just do this for now, because I want to make sure that it's working. Blockchain test, let's go. Tests get header. So how are we going to test this? Let's add a couple blocks, and then we're going to fetch them. Assert no t bc. Wait, it's not going to work like this. Header hash is bc and get header I plus 1. Make sure that the error is nil, and then assert equal t headers b.headers block and headers. So we're gonna insert a couple blocks, we're gonna fetch all the headers, we're gonna make sure the error is nil, and we're gonna make sure that the header we fetched is the same as the block. Yeah, that should be good. Alright, we fucked. Index out of range, so we made a mistake. Add block. Wait, this is height, I guess. It's gonna be the same, to be honest. Yeah. So we add a block and we get the header, the block print height, which basically means this validated blockchain. So we get header. Wait, I'm confused. If the height is higher than the BC height, that's impossible. And wait, let me, what is this? So basically we have Genesis block 1. So if I want to grab block 1, I need to have, yeah, 2 in, oh wait, but it's len, god damn it. Yeah, so, yeah, yeah. Oh my god, I'm confused because I'm thinking if you do len of an array, you get, for example, let's say you have an array with 2 things, right? So if you do len array, you get 2. But if you want to have the first thing, you don't say 1, you say 0, right? So what the hell? It's too early in the morning. I'm sorry. Let me quickly sip of my coffee so we can eliminate these rookie mistakes, ladies and gentlemen. Yeah. I could, basically I could cut this out of the video and it's all good, but I'm not gonna do it because we all make these stupid mistakes. So let's test. Yeah, cool. So hey, you're not the only one making those stupid mistakes. It's also me. Excuse me. So let's get header. This is working. That's good. So now we need to go back to our blockchain validator actually. Yeah. So what we're gonna do is, yeah, here. So we have our pref header. And now we need to hash this and compare. But I can directly spot an issue because so basically the pref header, we need to have the bytes and compare this. The problem is, guys, that if you open block, what we did here is b.block.header header data, and if we do hash, we give it a block. So let's say we want to do hash is block hasher, like this, and we hash, we need to give it a block. The thing is, we don't have a block. So what we could do, a couple things. We could say, yeah, just go to storage, because in our blockchain, so there's the decisions we need to make. So in our blockchain, we have a list of headers, but we also have a storage. And this storage later on, which we're going to implement in future episodes, it's going to exactly store blocks, like the complete block with its transactions. But in our memory, because we want to be efficient, we only have headers. But that's enough, because a header contains all the data we need to calculate a block hash. But the problem is this hasher thing, it wants a block. And we don't want to go to disk. So we need to change this. And we're gonna do it like, instead of doing, we're gonna do something like func header bytes bytes. We're gonna do this. Up. We're gonna return the bytes of the header, and we're gonna delete this header data, and we're gonna change this to header. We're gonna hash the header. So we verify and we say, instead of getting the header data from the block itself, we're gonna say header.bytes, and I think here is the same. Header data header.bytes bytes, yeah. And then we have a problem in our hasher, I think. Hash t block hasher. It can be perfectly the same name. The only thing we need to do is change this to header, and then change this to oh wait, no, bytes, like this. Okay, so now what we can do is say, wait, I think some tests are failing. Wait, why are the tests working, to be honest? Anyway, doesn't matter. Block hasher hash, we give it the pref header, and then we're gonna say if a hash is not equal to block.pref block hash, we're gonna say the hash, come on man, the hash of the previous block is invalid. The question rather is, what do we print to the screen? The hash of the previous block, this thing, is invalid. b.block hash. Okay, and now we are in big problem, because if we now run tests, everything is failing, and that's perfectly normal, because let's go to blockchain test. Yeah, because we don't have, let's open a block test actually. See, we do random block, and we say pref block hash is basically a type-spent random hash. So it's bad. It cannot work because it's just not correct. So how are we gonna fix this? Excuse me. So we need to basically pass in. So let's say this one, right? Test at block. We need to find a way to pass in the previous block hash. So let's start up with basically removing this too. I make always a practice of putting those helper functions on below everything. Let's do func get pref block hash. We're going to give it a testing.t, sure. We're going to give it a height, and it will return a types hash. And it needs a blockchain. we gonna say return bc.get header, and we say height -1. We assert the error, and then we say hash is gonna be, wait, we can do like return block hasher. Yeah, hash ref header, ref header. Yeah, I think this is good. Return block hash, yeah. And now we could say I think we can be fucked by the Genesis thing. It's gonna be 0, that's okay. Because the Genesis block will have a pref block with just 0 bytes, right? Random block with signature, and then we need to change this. So we need to have a pref block hash types hash pref block hash, and we need the same in here. Pref block hash types hash like this, and so the thing is, it's actually okay, because if we wanna test something with random block and we don't really need the pref block hash, we could do like types hash and do this and call it a day, right? Types hash, you don't need this. Okay, that's all perfectly fine. And now we could say random block with signature, and then we say get pref block hash tbc and uint32 I+1. Does this make sense? It does make sense. And then we do the same thing here, but to be honest, because we're cheesing here, so we're testing something that will not trigger this, so we could do types hash here, if that makes sense. Because in this case, we're really calling verify. I mean, if you open up blockchain, right? Let me explain. So validator, actually, man, this is getting the project is growing, yeah? So we need to, yeah. So basically, this test will make sure that we cannot add blocks that we shouldn't add, and one of these two things will capture it, and not this one. If that makes sense. So we can put any hash. It doesn't matter. It doesn't matter. Let me test this function, to be honest. Let's see. Okay, we fucked. Well, it's basically the other test that's complaining. Let's first fix them, to be honest. Random block with signature, the same thing here. Get pref block hash tbc and uint32 I1. Yeah. Block too high. So basically this means that could do type spent hash here, and the same here. Okay. Cool. So it's working. Okay. So something I want to do also is basically deciding what log package we're going to use, because right now we are just dumping it with format println, but we actually need something to log, and something I always use is go get getup.com, C. Rubson, I guess, logres. And we could do something in blockchain. Add block without validation. We could do logres with fields. Not sure if I'm doing it correctly. Logres with fields, I guess. .info. How does it work? Yeah. Adding new block. Yeah. And then we could say something height. Come on. Height is b.height. Yeah. And maybe a hash. b.hash. And it's the block hasher. Ah, yeah, it's this error. I encountered this. This is basically, if you have this error, it's basically, let me quickly look up, because you need to do, yeah, this has to do with an invalid internal package. And the only thing you need to do, because I had the same issue in another project I was playing around with, you need to do this command is go get golang.org x6. So this is basically this package that's out of date, and that causes the issue. So if you upgrade this and you do make test, it should be all work fine. Cool. So it's not logging our things because we disabled verbose, so we're gonna do it like this, and then you can see that we're basically adding a new block with this hash, with this height to the chain, and that's nice to have. Okay. Let's open up the validator to be sure. Validator. Actually, to be honest, it's kind of messy, those tests. Get pref block hash. DBC. Yeah, it actually. We can't. Okay, cool. So let's recap. Validate block. We check if the block already exists. We could do this in one pass. So these two lines, checking if the block is smaller or equal, and checking if the block is too high. We could do this in one thing, in one pass, in one line, but then we need to return one error. And maybe we make it more verbose, where we can say, okay, this block already exists and this block is too high. So that's why we split it up. Then we check if the pref hash of this block really exists. And you could do this in two ways, or you just grab the hash, grab the block by its hash, but then we need to go to storage. So we basically take the current height of the block, we subtract one, so we have the previous header, and then we hash it and compare it, and we should be good. And then we verify. And there is one thing, if you go to block and we go to verify, we're only verifying the block, but we should also verify all of its transactions. And a matter of fact, something I was thinking about of stream, so to say, is public key. I don't like this name. We're gonna name it from. It's more explicit, more clear. From. Because basically the public key of the transaction will be the public key of the sender. Actually, we could do sender, to be honest, but it makes more sense like this is the public key from the sender, from that client, if that makes sense. I think we're gonna have an error in tests by doing this. Let's open up terminal. Make. Oh, this keyboard, man. Oh my goodness. Make tests, you see, so it's basically in transaction tests. Boom. It should be from, all right. The problem also is, guys, my microphone is basically right in front of me, and it's a giant thing with a cable, and I need to be very carefully maneuvering my hand on my keyboard so I don't hit that cable, and it's pretty nasty, and that's why my hand is in an awkward position sometimes, and I cannot reach some keys. So I'm basically torturing myself recording these things. I was thinking to buy a new microphone that I could attach to my desk, and it's gonna be like a crane, you know what I mean? Like it's coming from the top, and then I'm free of hassle, of burden. Free of burden. Let me think. We are off track. Yeah, verifying transactions. So let's open up transaction. So we can verify transactions. So what we could do is just do like for TX range, even transactions. Yeah. And we say verify. There is no. We return the error. Yeah. And I think we're gonna have some errors again. Make test. Yeah. Transaction has no signature. All right. Perfectly normal. Test. Block test. Again, let's move this to the bottom. Wait. Yeah. Help. All right. Let's move to the bottom. Like this, and then. So we're making a new transaction here, but the problem is not signed. So we could do a helper function, random tx with signature. Oh, come on. Signature. T. Do we need the T? Yeah, we need the T. Transaction. Tx is transaction data byte full. And we're gonna say assert the expense sign, which needs a pref key. Okay, generate private key, and we put it in here. Sig sign, and then we can return the TX. And then we can say TX is wait. Let's go to block real quick and do something like reference this. No, I'm not really sure what we're gonna do with this slice. Maybe we should have pointers, maybe we don't. Not quite sure, because most of the transaction is basically already a pointer. I will think about it later on. For now this is good, so we can add transactions. So we're gonna say, we're gonna instantiate this block with an empty list of transactions, and then in random block with signature, we're gonna say tx is random, tx with signature, t. And the reason why we don't pipe in this private key into this function is because most of the time this private key is basically is going to be the private key of the validator of the block, and that will not be the same as the client sending the transaction. Random takes with signature, and then we say b.add transaction takes. Yeah, I think that should be good. Yeah, so it's all working. Yeah. So now our block verifies its own signature and verifies every single signature of the transactions. In our blockchain, we have a validator. Let's open it up to recap. In our blockchain, we have a validator basically that's checking a couple things and comparing the previous hash, and then we do verify, which basically verifies the block and all its transactions. Yes. That's good. Yeah. I think blockchain that we are good. Of course there's gonna be a lot more functionality to it. I am aware. But like I said, we need to build this up. You cannot build it from the beginning. You need to gradually build this thing up and go further and further. And I'm thinking what we could do actually before we end this episode and go to the next one. So we could basically also, I think storage for now, we're gonna leave it open. Because storage is only needed for our RPCs or a JSON RPC if you want to retrieve a block, and for our protocol. Because other nodes can ask for blocks to sync, but for now we don't need it. That's for later. And I'm thinking, let's open up the test real quick to see if we have everything covered. Test. New blockchain. Has block. So maybe we could do like this. Okay. Test get header. All right. Could do here is do like this, for example, and we could say in this case it's going to be, because we're testing that okay, 3 is too high because the height is 0, so it should be 1, so that the hash doesn't matter. But if we want to test that this block is not too high, we need to do this. This is basically obsolete, but why not? I mean, why not test everything in depth? Because basically, if you create a test for something, you need to make sure that you test the positive result and the negative result, outcome of the test. But in this case, we need to have the get pref hash, because otherwise it's going to fail. TPC and then uwin32. 0. No. Okay. What the hell is this? Given height to high. So we do a with Genesis 0, and then we add this block. I'm shooting myself in the foot by doing this test. Oh man, what is this? So basically, if you do this, then it should work. Make tests. Yeah. So it's basically this. So we say assert nil, add a block, a random block. The height is 1, and the get pref block hash should be. Ah, wait. Yeah. No. It should be 1, to be honest. But I don't understand. It's gonna fail anyway. Is it? No. Yeah, cool. So the problem is here that get pref block hash expects basically the height of the current block. It's basically, where is this thing, this helper here, you see? Because we're subtracting it right here. Because otherwise we should call this get block hash. And then this could be the normal height. But we want to say get the previous block hash. And we give it the current height. And then we subtract 1, if that makes sense. Yeah. Okay. Do we need to have more? New blockchain with Genesis. Yeah. Okay, no, we're good. So I think the blockchain structure is okay for now. I think the validation is pretty good. So what we don't include basically right now is, let me explain this a little bit. Let's close this, is state transitions. So basically what happens is each blockchain has a state, and let's call this state D of S maybe. And each time a transaction comes into the system, we transition from state to, how do those engineering guys, those scientific guys say this, state prime or something. So we basically transition from state to another state, and that will happen also here. So each time we add a block, we verify everything, we verify every transaction, and then based on how we're going to implement this in the future with a VM or whatever, we're gonna say we're gonna need to run each transaction and transition the state to the next state. And we should make this, and that should be deterministic. So if each node does this, they end up with the same deterministic state for every node in the network. And that's basically a very, it's not complex, but it's a very dangerous thing, because what happens if we modify the state and something goes wrong, because we have a batch of transactions and everything can go wrong? How do we solve this? Because if you have 10 transactions, let's say you have 10 TX, you need to do 10 times a state transition. And let's say the first 1 to 5 transactions were perfectly fine, and the 5th one is failing. Yeah, then we are fucked, because then we need to roll back the state. But we're gonna fix everything. We're gonna make it perfectly fine. We're gonna make it insanely good. I have some ideas to handle that. That's something we need to do. But I think for the next episode, we're gonna go back to server, and we're gonna add the blockchain into the server, and we're gonna start adding transactions. So we need a mempool in this, and we're gonna start filling up the mempool. We're also gonna say we're gonna make sure that the server can be a validator by giving it a private key, so it can sign blocks, and then we can propose blocks to the network so other nodes can sync. And that's all good stuff we're gonna do in the next episode. So it's gonna be amazing. I think this is it for episode 6. Like always, if you like what you see, give me a thumbs up, subscribe to the channel, leave some comments. Thanks for watching, and see you in the next episode.